For more than 150 million years, they were the undisputed rulers of Earth. And then, poof, in what was basically the blink of a geological eye, they were gone. The extinction of the dinosaurs is, without a doubt, one of the greatest cold cases in the history of our planet. So today, we're going to open up that file and see if we can figure out what really happened.
Now, this is not a simple open and shut case. We've got two prime suspects, two absolutely cataclysmic events that happened right around that 66 million year mark. So, was it a killer from space, or was the planet itself the culprit? To really get what happened to them, you have to understand the world they lived in. The late Cretaceous period, it was a warm, lush, thriving planet. Dinosaurs weren't just getting by, they were everywhere, from the poles all the way down to the tropics. They were an incredible success story. And then, the trail of evidence begins. All right, let's start with our first suspect. This is the one you probably know, the one you've seen in all the movies, a massive rock from space, an event of almost unimaginable power. Let's take a look at its rap sheet. You know, it's really hard to wrap your head around the scale of this thing. Just try to picture an asteroid the size of Mount Everest hitting the Earth. It left a crater wider than the entire state of Connecticut. And the timing? A perfect match for the extinction. But here's the thing. An explosion, even one this massive, doesn't just wipe out an entire planet's dominant species. So how did it do it? What was the actual kill mechanism?
Well, the leading theory is something called an impact winter. The idea is that the impact vaporized the ground and threw trillions of tons of dust and sulfur high up into the atmosphere. This cloud of debris would have wrapped around the entire globe like a shroud, blocking out the sun for years, maybe even decades. Photosynthesis would grind to a halt, plants would die, and the planet would plunge into a deep, deadly freeze.
But just when it feels like the case is about to close on the asteroid, another suspect emerges. This one had the power to poison the atmosphere, not from space, but from deep within the Earth itself. Let's talk about the Deccan Traps.
Now, we're not talking about just a few volcanoes here. This was a flood of lava that covered an area the size of modern-day France, and it erupted, on and off, for hundreds of thousands of years, right across that extinction boundary. It pumped unbelievable amounts of carbon dioxide and sulfur dioxide into the air, enough to totally rewrite the planet's climate. So, this leaves us with two totally different scenarios. You have the sudden, violent shock of the impact causing a catastrophic deep freeze, and on the other hand, you have this long, slow poisoning of the atmosphere. How in the world could we figure out which one was the real killer?
Well, you build a digital time machine. Scientists use these incredibly sophisticated climate and ecological models. They basically took everything we know about where dinosaur fossils are found, combined it with advanced atmospheric simulations, and built a virtual late Cretaceous world. And then they unleashed both catastrophes to see what would happen. Let's check out the results.
Okay, so first, the control experiment. This map shows the baseline model of the dinosaurs' world. All the green areas are places on Earth where the climate was suitable for them to live. As you can see, it was a pretty good time to be a dinosaur. Their habitat was everywhere, and it was stable.
All right, time for our first test. Let's just pretend the asteroid never happened for a minute. What would the massive, long-term Deccan Traps eruptions have done to this world all on their own?
And right away, we get a huge surprise. The long-term effect of all that volcanic CO2 was, well, global warming. And the models show this warming would have expanded the suitable habitat for dinosaurs. It would have made even more of the planet comfortable for them. So, far from a death sentence, the long-term effect of the volcanoes was actually good for them.
Okay, but what about the short-term cooling you get from all that volcanic sulfur? Well, the model showed that, yeah, it did cause some climate stress, but it wasn't a global killer. The key thing is, it left these huge refuges of suitable habitat around the equator where dinosaurs could have easily survived. So, it looks like suspect number 2 has an alibi. It wasn't the primary killer.
With the volcano seemingly off the hook, all eyes now turn to suspect number 1. So let's run the simulation again, but this time we're going to model the effects of that 10-kilometer-wide asteroid slamming into the planet.
The first result is just staggering. In the years after the impact, the average temperature on land dropped by more than 34 degrees Celsius. That's over 60 degrees Fahrenheit. Think about that. It's like going from a nice fall day to the coldest temperature ever recorded in Antarctica, in an instant. And it wasn't just the cold. The impact winter also completely shattered the planet's water cycle. These models predict that global precipitation, rain, dropped by 95%. The world pretty much became a frozen desert overnight. And the final result is chilling.
When you take that dinosaur habitat model and you project it onto this new, frozen, dark world, it's just gone. Every single square kilometer of suitable habitat on the entire planet is wiped out. There was simply nowhere to run and nowhere to hide.
So the evidence from these models, it seems pretty overwhelming, right? We have our culprit. But this investigation isn't quite over. There's one final twist to this story that really changes how we think about the whole event.
Okay, so the verdict is in. The asteroid impact and the catastrophic impact winter it triggered, that was the primary kill mechanism. The climate models are clear. It was powerful enough to completely destroy the global habitat for non-avian dinosaurs, something the Deccan volcanism just couldn't do. Case closed? Well, not quite.
And here's the twist. The models didn't just show the destruction, they also showed what happened afterwards. So, on its own, the climate would have taken about 30 years to recover from the impact winter. But, and this is the crazy part, when the scientists added the background warming from the Deccan volcanoes back into the simulation, the planet's recovery happened a full decade faster.
It turns out our second suspect was playing a completely different role than we thought. The CO2 from the Deccan Traps, which is already warming the planet before the impact, it acted like a buffer. It helped counteract the extreme cold of the impact winter, preventing an even deeper freeze and helping the Earth's climate bounce back much more quickly.
This quote from the actual research paper really sums it up perfectly. Instead of thinking of the volcanoes as a co-conspirator in the extinction, we now see they might have actually been a mitigating factor. I mean, they couldn't save the dinosaurs, but they likely helped save countless other species that did survive, setting the stage for the recovery of life on Earth. You know, the case of what killed the dinosaurs reveals a really profound truth about our planet. Even the most dominant forms of life can be wiped out by a single rapid event. For 150 million years they adapted, they thrived, but they just couldn't survive one terrible, catastrophically bad day. And it leaves us with a pretty critical question to think about: just how resilient is our own world to the rapid changes that are happening right now?